Here I'm going to go through some financial maths, specifically relating to the formula needed to answer some of the past paper questions on the course. I'm going to start with the formula that are in the log tables, so I'll just put them up now. And to begin with, we're going to look at this, okay? Compound interest. Compound interest is interest that grows each year because it's calculated from a new principal amount. So what that means is, let's just say you have a certain amount of money that you have saved in the bank. And to start with, that sum of money is called the principal. And you want to know what is the final amount of that principal worth after a certain number of years. What's going to happen is the bank are going to apply an interest rate based on the principal amount. So you're going to start with a certain amount of money, and then the bank is going to pay you money for having that original amount, which is called the principal, in the account. So at the start, you might have a starting value of €1,000 saved in the bank, and the bank might give you an interest rate of 4%. Well, if you've let that €1,000 in the bank for 1 year, at the end of that year, so this will be year 0, at the end of that year, the new final amount for that amount of money will be the 1,000 times 4%, which is just 4 over 100, plus the original amount. Another way of writing that is just going to be the original amount times 1.04. And that value is going to be €1,040. If you were to keep that money in for a second year, then the interest rate that the bank is going to give you, let's say it's still 4%, that is going to be charged on the new principal, which is 1,040, not the old principal, which is 1,000. And if we want to see how much that money is worth at the end of year 2, that's going to be our principal times 1.04, assuming it's the same as interest rate, which is equal to 1,040 times 1.04, which is 1,081.60. So at the end of year 2, that value is now worth €1,081.60. Okay, to calculate that in one go, what we could do is simply just write that the final amount is going to be equal to the principal times whatever the interest rate is to the power of the time over which that interest rate is charged. So in one step we could say that the future value would be 1,000 times our interest rate, which is 1 plus 0.04, which is 1.04 to the power of 2, and that will give us our 1,081.60. So that's a quick way of calculating future values of investments. It's worth noting that in terms of our interest rates, usually if we're dealing with annual interest rates, you'll find terms such as APR, which is the annual percentage rate. Now that's the annual rate of interest charged, which is usually used for loans and mortgages. Or else you might hear of annual equivalent rate, which is AER. Now that's a rate of interest paid on investments. So for savings and things like that. So there we would have been talking about an AER for savings. If you can use this formula, then you'll have a good chance of getting marks on the paper, okay? Where F is just the final amount, P is our principal, so our original starting amount, I is the interest rate, and which is usually as a decimal, and T then is our time. So this is a really popular question. If you want to convert an AER, which is an annual rate, into a monthly rate, then we're going to just assume that the original starting value is 1. So if 1 is our principal and we want to find out what a new interest rate is in a month, well, there's 12 months in a year, okay? And if we know that the AER, which is the annual rate, is something like 3%, then the final value of the amount of money, which is 1, the principal, after an interest rate of 3% is going to be 1.03, because it's going to be 1 plus the 0.03. So all we have to do here is rearrange the equation and try and calculate what I is. Like if 1.03 is equal to 1 times 1 plus I to the power of 12, then if we get the 12th root of both, we have 1.03 to the power of 1/12, or the 12th root, is equal to 1 plus I. So therefore our interest rate, which I'll just write here, is equal to 1.03 to the power of 1/12 minus 1. So you just plug that into the calculator, 1.03 to the power of 1/12, and we're just going to subtract 1 from that. And so the interest rate there is 0.00247, which is equal to 0.247% per month. This question actually came up recently enough in 2017, paper 1, question 8. You're told that the annual percentage rate charged on debt by a credit card company is 21.75%. So your APR 21.75%. For the fixed term of the debt, find as a percentage correct as 3 significant figures the monthly interest rate that is equivalent to an APR of 21%, or 21.75. So we're asked to find the monthly interest rate if the annual interest rate is 21.75%. Well, we're going to assume that the principal is 1 when we're just looking at sorting out the interest rates. We're going to have our APR is 21%. So after 1 year, the value 1 has increased by 21.75%. So our final value is going to be 1.2175 is equal to the principal times the monthly interest rate. So therefore, our interest rate, just rearranging all that and keeping interest rate on the left hand side, our interest rate is 1.2175 to the power of 1/12, taking the 12th root of both sides, okay, and then subtracting 1 from that. Okay, just do that in one step there. That gives a value of 0.0165. And that's as a decimal, so that's going to be an interest rate of 1.65%. We just multiply it by 100. So practice a few more of those questions because they come up quite frequently. The next video will look at some of the more complicated questions involving compound interest.